LEQ Audio presents Types of Operating System, Concepts, Working, Advantages, and Examples. Introduction. LEQ Audio welcomes you to this detailed audio lesson. Hello, everyone. In this audiobook, we will study one of the most important and frequently asked topics in operating systems, types of operating system. Understanding the types of operating systems is essential because different systems are designed for different purposes. Some operating systems focus on speed, some on fair resource sharing, some on real-time response, and some on network or distributed environments. This topic is extremely important for BCA and MCA examinations, GATE and UGC NET, competitive and technical interviews, practical understanding of real-world systems. We will move step by step from basic types to advanced operating systems with clear explanations, examples, advantages, limitations, and real-life relevance. What do we mean by types of operating system? An operating system can be classified into different types based on number of users, number of tasks, processing method, time constraints, system architecture, usage environment. Each type of operating system is designed to solve a specific computing problem. 1. Batch operating system. Concept explanation. A batch operating system is one of the earliest types of operating systems. In this system, jobs are collected in batches. Similar types of jobs are grouped together, and jobs are executed one after another without user interaction. The user submits a job and waits for the output later. Working of batch operating system. Input jobs are prepared using punched cards or files. Jobs are stored in a queue. The operating system selects a job. The job is executed completely. Output is generated after execution. Key characteristics: no direct interaction with users, long turnaround time, simple scheduling, high CPU utilization for similar jobs. Advantages: efficient for large volumes of similar tasks, reduces setup time, better hardware utilization than manual processing. Disadvantages: no user interaction, difficult to debug programs, one job failure may affect others, not suitable for real-time applications. Examples: early IBM mainframe systems, payroll processing systems, bank statement generation. 2. Multiprogramming operating system. Concept explanation. In a multiprogramming operating system, multiple programs are kept in main memory at the same time. The main objective is to maximize CPU utilization. When one program waits for I/O, the CPU switches to another program. Working principle. Several programs reside in main memory. CPU switches between programs. Idle CPU time is minimized. OS manages memory and scheduling. Key characteristics: multiple programs in memory. Efficient CPU usage. Requires memory management. Requires scheduling algorithms. Advantages: high CPU utilization, improved system throughput, efficient resource usage. Disadvantages: complex OS design, requires large memory, possibility of deadlock, difficult error handling. Examples: early UNIX systems, mainframe operating systems. 3. Multitasking operating system. Concept explanation. A multitasking operating system allows a single user to run multiple tasks simultaneously. Here, the CPU switches rapidly between tasks, creating the illusion of parallel execution. Types of multitasking: preemptive multitasking, cooperative multitasking. Preemptive multitasking: OS decides task switching. Each task gets a time slice, more stable and secure. Cooperative multitasking: task releases control voluntarily, less overhead, less reliable. Advantages: better user experience, high productivity, efficient CPU utilization. Disadvantages: context switching overhead, complex scheduling, requires fast hardware. Examples: Windows, Linux, Mac OS, Android. 4. Time-sharing operating system. Concept explanation. A time-sharing operating system allows multiple users to share a computer system at the same time. Each user gets a small time slice of CPU. Working mechanism. Users submit commands through terminals. CPU time is divided into slices. OS switches rapidly between users. Quick response is provided. Key features: interactive system, fair resource sharing, fast response time. Advantages: supports multiple users, efficient use of CPU, interactive environment. Disadvantages: security concerns, overhead of context switching, performance depends on number of users. Examples: UNIX, Linux servers, multi-user database servers. 6. Real-time operating system. Concept explanation. A real-time operating system is designed to respond within a fixed time constraint. In RTOS, correctness depends on result and timing. Delayed response can cause system failure. Types of RTOS. Hard real-time OS. Deadlines must never be missed, used in critical systems. Soft real-time OS. Occasional deadline misses are acceptable. Performance degrades, but the system survives. Key characteristics: deterministic behavior, fast interrupt handling, predictable scheduling. Advantages: high reliability, precise timing control, ideal for critical applications. Disadvantages: expensive development, limited multitasking, complex design. Examples: embedded medical systems, aircraft control systems, industrial automation. 7. Distributed operating system. Concept explanation. A distributed operating system manages a group of independent computers and makes them appear as a single system. Each computer has its own memory and processor. Working concept. Nodes communicate via network. Tasks are distributed. Resources are shared transparently. Features: resource sharing, scalability, fault tolerance. Advantages: high performance, load balancing, reliability. Disadvantages: network dependency, complex synchronization, security challenges. Examples: distributed databases, cluster computing systems. 8. Network operating system. Concept explanation. A network operating system is designed to manage network resources and provide services over a network. Unlike distributed OS, each system is aware of other systems. Functions: file sharing, printer sharing, user management, security control. Advantages: centralized administration, easy resource sharing, improved security. Disadvantages: requires dedicated server, network failure affects system, costly setup. Examples: Windows Server, UNIX Server, Linux Server. 9. Single User Operating System. Types: Single User Single Task OS, one user, one task at a time. Examples: early MS-DOS, Single User Multitasking OS, one user, multiple tasks. Examples: Windows, Mac OS. 10. Multi-User Operating System. Concept explanation. Allows multiple users to use the system simultaneously. Features: user authentication, resource sharing, security mechanisms. Examples: UNIX, Linux servers, mainframe OS. 11. Embedded operating system. Concept explanation. An embedded OS is designed for dedicated hardware systems. Characteristics: small size, fast boot, specific purpose. Examples: washing machines, smart TVs, routers, cars. Comparison summary conceptual. Operating systems differ based on number of users, time constraints, processing style, hardware environment. No single OS is best for all purposes. Importance for exams. Questions are commonly asked on differences between OS types, RTOS versus time-sharing OS, distributed versus network OS, batch versus multiprogramming OS. Conclusion. An operating system is designed based on purpose and environment. From simple batch systems to advanced distributed systems, each type plays a crucial role in modern computing. A strong understanding of OS types builds conceptual clarity, practical understanding, exam confidence, career readiness. To listen to more detailed, exam-oriented audiobooks like this, download the LeQ audio app from the Play Store. Visit and log in at www.leqaudio.com. LeQ Audio. Learn anytime, anywhere.